This is your objective, right? This is the main objective. So I want you guys to write this down. So write this part down. Alright, so this first one, right? OF, just like how we just usually do it, like O to F, we could also call OF by a letter, okay? So it's just like having a shortcut. Instead of just saying, oh, I'm going from O to F, you could say I'm using the B line or the C line, the A line, okay? But O to F still represents a vector. So if you're looking at this, for instance here, OF, all right, is the same as this A here, okay? So when you draw this A with a arrow on top of it. So A is negative 5, 9, just like OF is A, which is negative 5, 9. They're the same thing. So just how we was using O to F before, instead of just calling it O to F, we call it A. Does that make sense? And O to G, what we call it O to G, right? So if O to G is B, what do you think G to O is? No, negative B. Don't overthink it, you know. Literally. So if O to F is A, I'm assuming that going from O to A, O to F is the direction that we have here. You see this arrow pointing from O to F? This highlights to me that, okay, if I'm going from O to F, I call that positive A. Okay, so if I'm going opposite now, opposite to that F, then that would be negative A. Okay, so let's try the first one, O to F. I want you all to write this down. So if we have O to F, we say we refer to O to F as, what do we say we refer to as? A. So I want you guys to put that down. So we gotta walk this one. So O to F is A with my little arrow at the top. Make sense? Now I want y'all to try OG, FO, GO if you're feeling very lucky and confident. You sure?
Yes.
How would you write that? You sure? Think about it. We getting there. Negative A plus B. So let's go through that. So OG is actually what? Tell me. OG is B. And FO is what? Negative A. Okay? FO is negative A. What is GO? Negative B. No. Remember what we used to say. If I want to get from F to G, what do I have to do in this instance? What's the common point? Oh, so I would say FO. We're using our same principles from last time. FO plus OG. And what is FO? We said FO is negative A. And we're adding that to OG, which is B. So you could write your answer as negative A plus B, or what's another way of writing this? Try again. B minus A. Right? That principle is we have a positive B and a negative A. So we have to do that. But what I like to do, I like just to stick with this negative A plus B. But it's good to know that B minus A is also an option in case they ask you whether or not that's the answer. If you understand what I'm saying. Now G to F. Without us trying to work it out using this process, what do you think G to F would be? Negative B, A, right? Plus A. Negative B plus A. So then that's like saying G to O plus O to F. Okay, I think somebody else was saying A take away B, right? So GO would be negative B plus OF, which is A. So we could also have this as what? A minus B. Does that make sense? Right, so the thing is, we want to express FG as a column vector if A is this and B is this, right? So currently we said that FG is what? Excellent. Y'all doing good, man. Y'all making me feel like this topic too easy for you. So then this here now, we have minus on the outside, open brackets, negative 5, 9. Oh, I'm going to add this to B, which is 7, 3. Now the question is, where did I even get all of this stuff from? Can someone explain to me? Okay, good. Now, I kind of confused about this minus on the outside. Like, where did I get this from? Why I got this minus here? Okay, excellent. So now, how does that help me with this? Like, what does this turn this to? Good. So then when we said this negative and this negative, we're going to turn that to positive 5. And then we're going to have negative 9 at the bottom, right? Then we're going to add that to 7 and 3. So 5 plus 7 is 12. And underneath, we're going to have minus 6. Does that make sense? Good. Now look what it says. It says M is the midpoint of FG. M is the midpoint of FG. It says F is the midpoint. M is the midpoint of FG. Write FM as a column vector. So I'll say that again. M is the midpoint of FG. So now, I want to break that down. So how in the world can I work that out? Anybody care to help me? So FG, come on, man, you're making this look too easy. So F to G is midpoint M, right? And as you said, if this is FG and M is the midpoint, that must mean that F to M, for instance, is what? Half of FM is half of FG. Okay, so FM is equal to half FG. Now, I don't know what FM is yet, but I know what FG is. And I worked out what FG is earlier, which is 12 negative 6. Now, I'm going to show this to you in two ways. The reason I'm doing it like this is because they said they want it written as a column vector. Okay? I'm going to also show you how we would do it if it was letters. All right? I'll show you how we would do it if it was letters. And when we do these ones here, O to M, M to G, we're going to try it as both letters and as numbers. Okay? So, what's half of 12? 6. So half of 12 is 6. And what's half of negative 6? Negative 3. Excellent. So FM is equal to 6 negative 3. So I just worked out what number 8 is. Does that make sense? Wonderful. So let's try it now with the letters. We'll try it now with the letters. So we have FM. Make sure y'all write this down. So FM with letters. So we say it's half of FG. So what is FG as letters? Anybody remember what FG is as letters? Minus 8 plus B. So if I had to write it as letters, this is how I could write it. I just put half, open brackets, minus A plus B. Or, y'all remember distributive law from algebra? Half times negative 8 would give us what? Negative half A. Half of B is just half B. Okay, so these are two ways to write down this part. Okay, so FM could either be written as this, which is a column vector aspect of it, or FM represented using the letters would be written as this. Okay, so I want y'all to take this down and we're going to talk about MG. We're going to talk about MG. How do you pick which one? So basically, what I'm doing here right now, right? I'm showing you both ways so you could see the connection between both. Okay? In a question, they would specify which one they want you to use. So they would say write the following in terms of A and B. Okay, so for all of these, we had to write them in terms of A and B. So for FM, we would have to written that as A and B, but I also asked to write it as a column vector so you could see the connection between the two. Now, usually, most cases in the questions, they wouldn't give you what A is equal to. They would just say it's A and they say it's B. You wouldn't know what these movements are. Okay, so if you say, for instance, doing a dance, remember we said that vectors, the top tells us whether we're going left or right, right? And the bottom tells us whether we're going what? Up or down. So think of me saying this is like, okay, we are dance crew, right? And we know our dance. So we got dance that we just call A. And A means what? 5 steps to the left, 9 steps up. Okay? So pretend now when I give you a question with just letters, I wouldn't put the numbers. But when I say A, somewhere in the background, something is happening. But we just know the dance itself is called A, but we don't know the specifics of the dance. So that's how they would give you a question oftentimes. So for instance here, I'm just telling you it's A, but you may not know the specifics of what A does. You don't know if A is 5 steps to the left, 9 steps up. But because I'm showing it to you here is the only way you know. Okay, so in an instance where you have a question, it's going to either be with the numbers or letters, and they will specify which one they want you to use. Does that make sense? My whole point here is just to show you that when they do give you letters, the letters are not just a random letter. the letters actually have some meaning behind it, just that they may not tell us. Okay? Make sense? Okay, so did we write this down now? Did we write it down? Y'all got this written down? Alright, so keep writing. You know what's interesting here now? I know what FM is. FM is half of FG. I know what FG is, so I just put a half next to it. Question is, what is MG? You think it's the same thing? So anybody else agree with him or we disagree? You agree with him? You sure? Good. I like that.
I agree as well.
I like the confidence. I like this is what I want y'all to do. You're either confidently right or wrong. You understand? But that's how we learn. We gotta be confident in what we're doing, cause we reasoning with ourselves. Okay, I made sense of it, so I know this is right. Okay? And then until you're proven wrong, you just gotta be able to defend why you say what it is. But it has to make logical sense. So what y'all saying is correct. MG would be the same thing as FM. Why? It's halfway. So F to M is the same thing as traveling from M to G. There's no difference between the two. So MG itself would also be half of minus A plus B. Now I'm writing it like this just because the question says write the following in terms of A and B. Okay? So I know that MG is gonna be half, open brackets, minus A plus B. Okay? So I know that that is the case. Alright, let's try the next one. Alright, so let's try OM now. OM. Anybody want to explain to me how to do OM? Let's try to get a little bit of space here. So I'll bring back what FM is. By the way, did anyone use O to G and G to M? That is brutal. Jeez. We do both ways. Okay, so let's start with OM. So O to M is the same as O to F plus F to M. O to F is A plus, we said FM was half, open brackets, negative A plus B. So perfect for getting this. Once you got this, that's good. The thing though, what we need to do as well too is simplify. Okay? So what like terms do we see here? A. So by the way, the fact that I see y'all got this is good. This is brilliant. Okay, this is a good start. The fact that y'all get this is exceptional. Okay, the next phase of it is just simplifying. All right, so this is A, and then I have to open these brackets. So it's going to be half times negative A, which is going to give me what? Negative half. Right, so negative half A plus half B, right? So A plus negative half A. So what's A? Take away half A then. What's A minus half A? What you guys get? Wait. Hold up. What's if I got 1A? Okay, I got one apple and I take away half of that apple. How much I got left? Half an apple, right? So if you was unsure about this, remember in front of this A we have a 1. So then I would say 1 minus half. I could hear somebody in the background. Check your mic. So 1 minus half, you could put this in your calculator, or you could work this out and then you'll end up getting a half. So that's a way how to, help deal with these fractions, right? Then the next part says plus half B. Okay, so this here is my final answer. So half A plus half B. If you want, you could actually simplify. You could factorize this if you feel fancy, or you could leave it like this, right? Now just in case y'all are interested in factorizing it, you could just have the half outside. A plus B. Okay, that's a simplified version. No, we're doing it in terms of A and B now. That's fine. If you do that, good practice, right? It shows that you understand the concept. Okay, now y'all decided maybe let's try OG to GM, right? Some of y'all did that. So OM could also be that. I like the fact that y'all realize you could use alternatives and stuff too. So O to M. If I want to go from O to M, I could go O, go to G, then from G, go to M. So then I take that other path. I take a other road. So that's going to be OG plus GM. So the question is, what is OG? So OG is, what is OG? Excellent. OG is B. Now, question is, what is GM? So earlier we worked out MG, which we said MG was the same as FM, which was half negative A plus B. That's what we said, right? Now, guess what happens now? If we want GM, what do you think is going to happen? Right? It's going to change the sign. So it's going to turn from half, instead of negative A, you're going to have positive A, and you're going to have negative B. Why did that happen? Right. Remember, if I'm going A and I change my direction, that means I'm going minus A. So in this case, M to G is half negative A plus B. So that means GM must be half positive A minus B. We just swap in the signs because it's the change in direction. Negative, positive shows us direction. So we have GM is equal to half AB. We do the same thing, expand the brackets. So then in this case, we would have B half plus half times A is going to give us half A. Positive half, I think of this as positive half times negative B is going to give me minus half B. So what are the like terms here? We could put who together? All right. So B, full B, and negative half B plus half A. So what is B take away half B? Nice. Half of B plus half of A. So this here is literally the same thing as this. It's just that a half A is here, the half B is there. If we was to write this in alphabetical order, we put a half A in front and a half B behind. So the same thing we got here is the same thing we got over here for OM. So just remember, no matter how we do it, once we do it correctly, we will get the same answer. So what I want y'all to do is write down the both versions that we just used so you could know that there are different ways to do it whenever you look back, okay? Remember, we want to write notes. Jamai, make sure you write your notes. All right, let's try a next question now. All right, let's go through it now. So, OK can be represented as what? Lovely. And OJ can be represented as what? D. How about KO? Negative C. And JO is what? Negative D. What is KJ?
Negative C plus D.
Negative C plus D. Now remember, KJ is the same as what? K to O plus O to J. So we know what KO is. KO is negative C and OJ is D. All right, so express KJ as a column vector. So we know that KJ is negative C plus D. So we could replace this negative C with what? Good. Negative 8, 6 plus 6, 4. Wonderful. So negative 8 will turn to positive 8. So we have positive 8, negative 6. Good. And here we have 6, 4. So we end up trying to add these two. So we'll end up with 8 plus 4, which is 8 plus 6, which is 14. So negative 8, minus negative 8 gives us positive 8. 8 plus 6 is 14. And then we have negative 6 plus 4, which is negative 2. So answer for this is 14, negative 2. So the question says no. Oh, I put the arrow at the wrong place. This actually is up here. The next question is J to K. What is J to K? Negative D plus C. So those of you who like to see visual stuff, if I'm going from J to K, I could go like this. I'm going the opposite of this arrow. So I'm going negative D, and then I'm going this way, which is C. So negative D plus C. And then to go from K to J, it's like going K to O is negative C because we're going opposite of the arrow. The arrow is pointing this way. Now, how do I know the arrow is pointing this way? The vector is going from O to K. So if you look at this, O to K is the arrow, which is equal to C. Now, this one says O to J is equal to D. So that means O to J is D. The next part says L is the midpoint of KJ. So how do we write KJ as a KL as a column vector? The first thing we need to do, right? Find what K to L is, but how we would do that. So K to L is half of KJ. So the thing is now we could go from K to L, draw that's midpoint, and then we have an idea of what it looks like approximately. Okay, remember last time we had ratios and stuff, which is possible to get for this as well too, but in this case we have one line here. So KL is equal to half KJ. So what is KJ? We already know what KJ is. KJ is half of KJ is minus C plus D, and KL would be half of that. So how did we get KJ? We went the opposite way because we said K opposite of this here, K to O, is negative C. Because we are going from O to K as positive C, K to O would be negative C. We are going opposite of the arrow. And then we add that to O to J, which is D. And then half of that is basically the trip to K from K to L. Now, L to J is the same thing as K to L. L to J is the same thing. So LJ would basically be equal to this here. All right. So LJ is also equal to half minus C plus D. So now O to L. O to L. How do we work out O to L? OK first, we go from O to K plus K to L. Now remember, we could also go the other way, so we could also go from O to J, then J to L, but we're going to go from O to K, then K to L. So that would give us what we have here. So OK, what is OK? OK is C, and we're going to add that to KL. Now what is KL? KL is half of minus C plus D. So half minus C plus D. Now generally, this could be the answer. However, remember, sometimes we try to simplify it because sometimes they ask us other questions as well. So for instance, in this case, we could say C plus half times negative C would give us negative half C, and then half times D would give us plus half D. Now the thing is, C, take away half C is what? Half C, great. Plus half D, and that's our answer. Now the thing is, if we had a calculator, it doesn't matter what fraction it is. Whatever number is here, we would say 1, take away that. If it was 5, we would say 5, take away half. If it was 4 plus 3 over 7, we would say 4 plus 3 over 7. Work it out the same way to get our answer. So that is the answer. So if you didn't have that, take it down and we'll try a next thing. We'll just add a little twister to see how we all handle it. And then after we look at comparing it to figure out if they have a relationship. Because remember, when we talk about geometric relationships, we usually try to see if they are. What do we look to see if they are? Parallel, the size, similarity, and collinear. Excellent. All right, you guys should have this by now. Think you guys could do this one now. Let's see how y'all gonna do this one here now. Okay, so let's see how y'all do this one here now. I'm interested to see how y'all handle this one. Just a letter. Just a letter. I'm looking at this here, and this should be. By the way, Kishaniz, that was a very good question. How we looking? How we looking? On which one? Okay, that one. Okay. Don't worry, we going through it soon. But just try, see what you can get out of it, and then we. That's fine. That's fine. 5. Well, keep it as a fraction. All right, let's try this now. So OA is what? What can we say OA is? 3A. What is OB? Lovely. 2B. What is AO? Nice. Negative 3A. What is BO? Negative 2B. What is AB? What's AB? Negative 3A plus 2B. So, Kristen, to your question, can we simplify this? How would we? They're not like terms. You see it? You follow now? So, going from A to B. So, A opposite of A to O gonna give us the negative 3A. Then when we add OB, we're going to get 2B. So, we're going to get negative 3A plus 2B. So, negative 3A plus 2B is giving us A to B. All right, that gives us A to B. Now BA, what do you think BA is going to be? So because we're going opposite here, this is going to give us negative 2B plus 3A. So negative 2B plus 3A. So as you can see here, once we have this here, it's just going to swap the signs, all right? So negative 3A turn to positive 3A, and positive 2B turn to negative 2B. Now the next one, we want to express AB as a column vector. And A is equal to this, B is equal to this. We need to figure out how to put that as a column vector. So what we do is, we know that AB is, let's do it over here. We know that AB is equal to negative 3A plus 2B. So then we're going to have minus 3 multiplied by whatever A is. So in this case, A is negative 5 and 9. So we're going to add that to 2 multiplied by whatever B is, which is 7, 3. So negative 3 times negative 5 is what? 15 and negative 27. Remember, a negative times a negative is a positive, and a negative times a positive gives us a negative. We're going to add that to 2 times 7, which is 14, and 2 times 3, which is 6. So 15 plus 14 is 29, and negative 27 plus 6 is negative 21. Anybody got this answer? Lovely. So let's try for G now. So G is the midpoint of AB. Write AG as a column vector. Okay? So how would you write AG as a column vector? Half AB. And what is half AB? Right? And then this part 2. But remember, we already got AB. Look what AB is as a column vector. So remember, if AG is half of AB, we already know what AB is, right? We are looking at it from a column vector point of view. So half AB. So AB is 29, negative 21. So 29, negative 21. So half of 29 is what? 14 and a half, or I could put 29 over 2, right? In this case, I'm going to just use 14.5 just for the ease of it right now, yeah? But try to keep it as a fraction. And for this, it's negative 10.5, all right? So that is AG as a column vector. All it is, AG is half of AB. Now, if I had to write that as a vector in a form of AB, what we'll do the same thing. So we'll say AG is half of AB. So what is AB as a column, as a expression in letters? Negative 3A plus 2B. So then we would say half of that would be minus 3 over 2A plus 2 over 2B, right? So what's 2 over 2? That's the same thing as 1, right? So that's just going to be B. And that would be my answer if I had to do it using letters as an expression. Does that make sense? It's a little tricky. It seems tricky, but it's literally just numbers. Don't let a fraction scare you. So half of negative 3, that's the same thing as saying negative 3 divided by 2. Yeah, you got, if you got it as 1 negative 1.5, that's fine too, right? But for calculation purposes, you just want to make sure that you could backtrack to this, okay? So negative 3 over 2 is the same as 1.5, but negative, okay? And half of 2, what's half of 2? Half of 2 is 1, so that's why 2 over 2 gives us 1, and that's our answer for AG. Does that make sense? Anybody lost for that? No, 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 no. We already found a column vector, right? What I said, what I showed you here was me saying, if we were to use it using the letters, this is what we would do. If we wanted, yes. So this isn't an answer to the question. This is just showing you, if they didn't ask for column vector but just using the expression for AB, this is how we do it. Okay? Does that make sense? Y'all follow this? Go ahead. Hit me. You can leave it like this, yes. Right? The reason why I'm doing it like this is to show you that that is a possibility. Okay? You follow me? And there's a reason why I'm showing you that is a possibility. Because remember, like in the last vectors we used to end up comparing vectors, right? So you might have to compare this vector with another vector. So in order to do that, the best way to do it is usually trying to simplify it, okay? So this here could work, yeah? But when you have to come down to comparing, you may have to break it down like this. Does that make sense? I know it sounds weird, but yes. You can have it like this, but sometimes you need to break it down like this. So I'm just letting you see everything. So when we do get to a question that requires that, you'll see what I'm talking about. When you say the proper way with the numbers and not the letters, what do you mean? In terms of here? Here. Yeah, you would write it like this, right? Just because, remember, our issue with decimals. Remember, if I do something like 5 over 3, right? Put that in your calculator, tell me what you get. 5 over 3. When you divide that, what you get? Exactly. Exactly. So that's the one reason why we leave it as fractions. Okay? I'm not saying decimals is incorrect, but when we write it as a fraction, we have the solid number itself as opposed to a reoccurring decimal. You see what I'm saying?
Yeah.
So it's easier to compare numbers that have a decimal a denominator than it is to compare with decimals, right? Because 1.33333 versus 1.66666 versus 1.99999, it's like, okay, how do we, draw the middle line between what is what? Versus if I have everything over 3, it's going to be like, so the third, it being over 3 is what's common, okay? When we get to more questions, like anytime we come across questions that involve whether we use a fraction or not, you start to see it. Like, say for instance, when we did graphs, when we used to find a gradient, remember we used to have to leave a gradient as a fraction. So the same concept here, same concept. Okay. Any more questions on this part before we go to GB? We good with that? Right. So okay, so with this part here, we have GB. Okay, so GB now, what is GB? GB is literally half of, what's GB half of? Right, so GB is literally the same as AG, right? So GB is half of AB. If we work this out, we're going to get the same thing that we did here because both of them are the same. A to G is like traveling G to B, same thing. Okay, so I know GB is going to work out to be this answer here as well. So this is going to be the same answer here. Make sense? All right, so let's try OG now. OG. So OG, how can we get from O to G? So OG is O to A plus A to G. All right, so O to A is 3A plus AG. Now AG is this up here. Okay, so Kishanis, this is where your question comes in. I could add this as well too. I could just put 3A plus half minus 3A plus 2B, right? And that could be my answer. You follow me? However, what if they ask me to put it in my simplest form? In that case, you would have to keep going smaller and smaller. Does that make sense? You would keep breaking it down. So if you was to write this back, anybody who wrote this back 3A plus half minus 3A plus 2B, that's fine too. That is fine. That's totally fine. But sometimes they ask you to simplify it. So you just need to know how to be able to simplify it. Okay, so it's not wrong. It's just, are you able to simplify it? Okay. Now, I know that 3A plus half plus minus 3 over 2. So 3 over 2 is the same as 1.5. So I know that when I add 3 plus negative 3 over 2, I'm going to get back 3 over 2. You guys could try it in your calculator. So this 3, just put in your calculator 3 plus negative 3 over 2, and you're going to get 3 over 2. So this here is my final answer for OG. O to A plus A to G. If I did O to B, then B to G, I'm going to get the same thing, just that I got to switch around signs and all that kind of stuff, and be careful with that. All right? Does that make sense? You have it as 1.5. Okay. But remember what we explained earlier about trying to keep it as a fraction as opposed to a decimal. Because in this case, 1.5 sounds perfect. That's a perfect number to have. But when we start to get like the 1.6676, and those kind of things, there's where it starts to get a little tricky. Yeah? Make sense? Yes. I would have leave it as either a fraction or a mixed fraction. So I would have just put 29 over 2 and negative 21 over 2. To be honest, I would have just leave it like that. I just did a 0.5 just to show y'all that, okay, hey, it's just half of that. And basically, in this case, it gives you that. So don't be scared if you get decimal number sometimes. In the sense of, like, when I say decimal number, I mean, like, if your number is not a flat number, don't get frightened. I think that what happened earlier with Barry. So Barry thought that because he saw a decimal, it's like, oh gosh, I did something wrong, right? Very good question. So B does not have anything next to it, because if you look at it when I had it here, you notice how it ended up being 2 over 2B, which is basically what? 1B, right? You follow me there? Okay, so when I simplified up here, so I said half of 2B. Okay? So what's half of 2B? That's basically just B. You following me? Okay, good. Now when I came to OA plus OG, what I'm adding is OA. What is OA? 3A plus AG. So AG, yeah, AG is minus 3 over 2A plus B. Okay? So AG is minus 3 over 2A plus B, which we got from this. Okay? Now, because I didn't have a B from the OA, I didn't have to add a B to anything. That's why the B just remained the same B that we have up here. Does that make sense? So if I had like 3A plus 7A, then this B, 3A plus 7B, sorry, then this B would have changed to the 8B. Okay? So that's why in this case, it just happened to be that B just by itself. You know what I mean? We ain't really trouble that B. You got it? All right, good. We add in a little section to it now. So prove that CD and LM are parallel. So I'll let you all try this. And then when we get to question 10, I want to see how y'all gonna do that. Then we're gonna run through this question together and see how y'all do. All right? So have a shot at this one too. All right, we finished? Make sure y'all focusing on the questions and getting them done. I'll definitely be checking these as well too. All right, you guys ready to try it? Okay, so OC, what is OC? That's 2C. What is OD? So O to D is what? 2D. Right. What's CO? Negative 2C. What is DO? Negative 2D. What is CD? Negative 2C plus 2D. Now they say L is the midpoint of OC. So L is the midpoint of OC. So in the midpoint here is OC. So I would guess that here is L. M is the midpoint of OD. So the midpoint from here is M. Now what is O to L? What do you think O to L is? Yes. OL is half of OC, which is half of 2C, which is basically C. So if I'm looking at this, O to L is like saying here is C, and then from L to C is also C. So we got a C here and a C here. That's how we got 2C. Does that make sense? So that means OL is equal to C. Okay, so Kishanis, that makes sense, right? So even though you got 1C, yes, that is the same as C. All right? Right. Okay, good. So what is OM? Right. Half 2D, which is D, right? So O to M is equal to half OD, which is the same as half times 2D, okay? OM is equal to D. All right, so L to M. L to M. So just looking at this from L to M. Wait, oh, go ahead, tell me. Why we did half of OC? Because OC, right? It says L is the midpoint of OC. So L is in the middle of OC. Okay? You follow me? L is in the middle of OC. Right? You follow me, right? So if L is the midpoint of OC, that must mean that OL is half of OC. Can you see that?
Yes.
So O to L must be half of the full O to C. You follow me now, right?
Yes.
Okay, good. So LM now. What is LM? Negative C plus D, or D take away C, right? Yeah. So the thing is, how did we get that? So if we're going from L, We said from L to O, O to M. So L to O, O to M. That's LM. So L to O plus O to M. All right. So L to O is equal to negative C plus OM. So OM is equal to D. So negative C plus D gives us LM. So LO is negative C, OM is D. Okay? So LM is equal to negative C plus D. Now the question says prove that CD and LM are parallel. So we have something for CD and we have something for LM. So CD is what? Negative 2C plus 2D. Okay? I'll put this part in brackets. All right? And then we have LM, I'll put LM here, is equal to minus C plus D. Now the question is, are these parallel? How? They don't share the same point. Try that again. They don't share the same point. Let's go. And good. Now, how you know? Because I don't know. I seen letters. I confused. How in the world you know that them scalar multiples of each other? So if I put CD here and let's try to factorize it. So the common factor between these two would be what? 2, right? So 2 comes outside minus C plus D. So in essence what you said, and we end up with minus C plus D, right? And over here now, when you look at these two, can you guys see that this says minus C plus D? This is minus C plus D. The difference is CD is just double this. Okay? Does that make sense? So LM is from here to here. So if I was to even draw it from L to M and draw from C to D, can you guys see that they're parallel? You see? So CD is parallel to LM. So we know because we are comparing these just like how we did it with the numbers. So we could see that they're scalar multiples of each other. All right? So CD and LM are scalar multiples of each other. So here I should actually say do not. Okay, so basically, right? When you look at CD, CD is minus 2C plus 2D, and LM is minus C plus D. Does that make sense?
Yeah.
Now, when you compare these two, what do you notice? Right, they have negative C and D, but not only that, it is not just negative C and D. If you look at it, if you factor out the 2, look what you get, negative C plus D, which leaves us just like this, negative C plus D. So then when we compare them, we could see that, oh, they kind of got the same vector thing going on, just that CD is twice the size. Does that make sense?
Yes.
So I know they're scalar multiples of each other, right? So then when I'm looking at this part now, from a graphical point of view, C to D and L to M are parallel. But remember, I draw this to scale, huh? So I know that this here are two parallel lines as well, just from observation. Does that make sense? Okay, so we just want to talk about the geometric relationships now, since we are entering into that phase again. Okay, so now, before we used to do the concept where we would divide, right? But what we have to do here now, we have to try and factorize. So this is simply a similar concept to what we did with the numbers part. Y'all remember we would divide the numbers, but first for this, we have to factorize, right? So for instance, OK. If I had to do OK and I factorize this, what's a common factor between these two? What's a factor? In this one here? 8. That's the highest factor. 4 is a factor, but I want the highest one, right? So A plus B. And what about FA? What's a common factor? Highest common factor? 4. Good. So open brackets A plus B. Now when you compare this, do you guys notice this has A plus B and this also has A plus B? Yes, but look at these numbers here. Now these numbers tell me how much bigger one is to the other. So based off of that, how much bigger is one to the other? OK is twice the size because now A divided by 4 is equal to 2. All right. So 8 divided by 4 is 2. So OK is twice the size of FA. So that's one geometric relationship. The second one, what can we say the second one is? Excellent. OK and FA are parallel. Why? Because they are scalar multiples of each other and do not share a common point. All right. So I want you guys to take this down and I'll give you a next part like this to compare. So what I'm doing is, as I do this, I want y'all to try to review the concept, understand what's happening. So essentially, you understand from the grand scheme of things how this works. So this is the other side of vectors. From here on out, after this is literally just practice. You know what I mean? Vectors requires practice. It's gonna really test your skills, but if you try to look at it from a perspective of traveling, like to get from one point to the next point, all I have to do is go from here to here, here to there. Once you could make sense out of that, you start to really understand what happens with vectors. But it's something you have to keep, your concentration levels high. Okay? Because it really requires you to think. All right, let's try the next one. Are there any geometric relationship between the vectors? So I want you all to try to work this out. Let's see what you come up with. All right, let's talk about this now. Are there any geometric relationships between these two vectors, CG and CH? Tell me. I'm not disputing you. CG is twice the size. But remember why? They are collinear. They share a common point, but they are also scalar multiples of each other. Okay? Don't forget that part. That's an important part. So CG could basically be factorized. We have the 6 outside, open brackets, A minus B. And then we have CH, which is equal to 12 A minus B. So then now, when I work this out, I'll have CH is equal to 12 and CG is 6. So 12 divided by 6, I know that it's twice the size. So the first thing is CH is twice the size of CG. How else can I say this? What's another way of me writing this or talking about this? CG is half of CH. So that's another way of looking at it. Good. So then the next part here, we could say that they're collinear. So they're collinear because they are scalar multiples of each other, right? Don't forget that part. And they share a common point. All right. So you could take this down. And then I'll give you all some more like this. So we soon finish. All right. Did we get it? Anybody figured it out? Okay. Let's try it. Let's go through it. So the first thing I'm going to do is try to factorize. So I know the highest common factor between 8 and 6. So let's talk about that in case y'all forgot, right? The factors of 8 are 1, 2, 4, and 8. Lovely. 1, 2, 4, and 8. What are the factors of 6? 1, 2, 3, and 6. So highest common. What is the highest common factor between these two here? 2. So I know my highest common factor is 2. Okay? Now, if I put 2 outside, what multiplied by 2 would give me 8x? 4. So then, what multiplied by 6? What would multiply by 2 would give us 6. So we have 3y. So when I walk this back, 2 times 4x gives me 8x. 2 times 3y gives me 6y. Does that make sense? All right, so let's look at this one here again now. So 12, 9. Factors of 12. 1, 2, 3. No, lovely. And 9 would be what? 1, 3, and 9. All right, so highest common factor is what? 3. Okay, good. So then we could pull a 3 out here. We could say that this here is equal to 3 outside, open brackets, 4x plus 3y. How do I know that? 3 times 4x gives me 12x. 3 times 3y gives me 9y. But notice, What do you notice when I compare these two? Mm-hmm. So that means they are scalar multiples of each other. Do they share a common point? No. So they're parallel. So they're parallel. Okay. They both are scalar multiples of each other and do not share a common point. Okay. So now that we have that, let's compare the next thing, the 3 and the 2. So if I said it could be 3 divided by 2, which gives us what? 1.5. All right, so that's it right there. So we know that CG is 1.5 times the size of AB, right? So I could say CG equal to 3 out of 2 times the size of AB.
I have a question.
Mm-hmm. Tell me. 12 divided by 8, 9 divided by 6. That's a way to compare it as well, too. Once you get back the same number, you know that they're scalar multiples of each other. Yeah? So it's the same concept like we were doing all the time before. Same principle. Yeah? Does it make sense? All right. Lovely. All right. So what I'm going to do is I'm going to give y'all a question to try for me for homework. I mean, obviously, this one is going to be easy, but I'll give you another question, like a full question, to see how y'all understand this concept, okay? So I'll send it to y'all in the chat for y'all to work on. All right? Anybody got any questions? Good, good. So I'll see you all. We'll try to do a next online class on Tuesday, and hopefully the school open Friday, and we'll have our next physical class. But I need y'all. I need y'all to work on practicing this stuff. No matter what happens, we still getting that exam May 9th. So we need to be ready for it. Okay? All right. So remember, Tuesday night Godspeed Life, all goes well. I'll keep you guys updated about that. And I need y'all to keep working on those other stuff. Please don't stop. All right? Please don't stop. Mm-hmm.